Okay, so last time we dealt with the law of diminishing marginal utility, the fact that as the supply of a good increases, the value of each unit of the good goes down. In other words, the marginal utility of the good goes down. And also talk about the demand curve being falling, and that's really, those are the two basic. Demand curve meaning how much the consumers will buy at any given price. I think I'll open the door here. Actually, that's a nice quiet air conditioner. I'm tempted to put it on, but anyway, we'll see if this works. Okay, and law of diminishing marginal utility is a key thing that this accomplished in history of economic thought. Adam Smith, the alleged founder of economics, actually he really wasn't, but he was, I guess, one of the founders of economics as a separate discipline. Said in The Wealth of Nations, which was the famous first classic, economic classic, said there's a value paradox, what's called value paradox, and he said he couldn't solve it. And that's very peculiar in history of thought, because he had solved it 20 years earlier in his lectures, which were published much later, about 1900 or something. So it's very peculiar, one of these peculiar situations in history of thought. In fact, it had been solved by the scholastic philosophers since the late 16th century. But all of a sudden he creates this problem called the value paradox. And it goes as follows, namely, how is it, why is it that things like bread and water, which are, let's take bread, it's usually called the diamond water paradox, but water has extra complications. At any rate, bread, which is the staff of life, it's very important philosophically to man, because you need it for life, and water, of course, even more. And yet here, bread is very important, has a high use value. And yet, on the market, it's very cheap. I mean, bread is, in those days, even much cheaper than a buck a loaf. Water in those days was free, quote unquote. But anyway, it's very cheap. So it's cheap on the market, therefore has a low exchange value. So, alright, that's one puzzling situation. Here's something which has a high use value and a low exchange value. On the other hand, this is bread and water. You can probably think of other things. Nails are pretty important for construction, and nails are cheap. Okay. On the other hand, you have other things which are luxuries. They're fripperies. And Smith, I think, is one of the reasons why Smith fell into it. Smith was a Scottish Calvinist. He wasn't a hardcore Calvinist, but he was a softcore Calvinist, and so he hated luxury anyway. He didn't like luxurious consumption. Diamonds are a mere frippery. They have, as he put it, they have no value, no use value. Okay? That's a little extreme. Most of us would say, well, they have, philosophically, does not have a very high value. It's a low use value. Diamonds. Crusoe and Robinson Crusoe and his desert island would not go for diamonds as his highest priority, obviously. And yet, look at diamonds. Diamonds are extremely expensive on the market. They have a high exchange value. Okay? And, well, this is a very strange thing. I can't solve it. And Ricardo, his disciple, said the same thing. Or more, we can't solve this. This is a value paradox. Therefore, we can't say anything about consumers, the value to consumers, the whole utility analysis. They can't say anything about it because they're stuck in this thing. They have to deal with the entrepreneurs and business and labor and all that sort of stuff. And consumer analysis drops out of the picture, except in France, where they never fell for this. But Britain has a dominant economic doctrine in the 19th century, and so we were unfortunately took 100 years to get out of this, to solve the value paradox. And from this idea, you see, comes the left-wing position, like Veblen and these other characters in late 19th century America and later, saying, well, capitalism, market economy, stresses production for profit and not for use. They produce things like diamonds, which are for profit, have a high value. They don't produce bread and water or something which have a low value, use value. All right, so this dichotomy between production for profit and production for use becomes very important in the history of left-wing thought. By this time you have the tools in your possession to realize the fallacy of this whole nonsense. The basic fallacy is this: people do not choose on philosophic value. We don't sit around deciding in one big vote, like a world vote. Supposing, let's put it this way, I like to use models. In macro, I use a model which I call the Angel Gabriel model. This is another angel. Let's go back to the model of the grand old, I consider the grand old science fiction movies of the 50s, 1950s and 60s, where some space character blocks into all television sets, All of a sudden, regardless of what channel you're on, some guy is speaking to you from the planet Ungu or something, and he hands Earthlings he says, Earthlings, listen, you have peace, conclude peace now or die in 6 days, or something like that. Well, the planet, some outer planetary character now comes to the Earth and he presents us with a choice. Okay, you got your choice, folks. From now on, you have a world parliamentary decision. You won't vote, on your TV set or something. You have a choice of losing from forevermore, from now on until the end of eternity, either all the bread in the world or all the water outside, whichever, or all the diamonds in the world. And that's the choice the human race is faced with. Well, given that choice, I'm sure we'd choose bread or water rather than diamonds. And the space people would, whoever they are, will go off with the diamonds. But the point is, in real life, we're not faced with this kind of a choice. We're not faced with all-encompassing class choice. We're faced with unit choices, marginal choices. The whole point of the unit. When somebody goes to buy something, they're not faced with a situation of, here's all the bread in the world versus all the diamonds. No, you're faced with things, should I buy this loaf of bread? Or should I buy this diamond with 12 carats or something? In that situation, the marginal unit becomes extremely important, and the law of diminishing marginal utility becomes decisive. Namely, it so happens that bread, for example, and water are superabundant. They're everywhere. Water, of course, is not so plentiful in some states and that sort of stuff. But basically, bread and water are superabundant. There's a huge supply of it. So even if you start, if there was one loaf of bread in the world and 1 gallon of water, you have a very, very high, this is marginal utility, let's say. And this is quantity, okay? If you only had 1 loaf of bread in the world for some reason, or one gallon of water, you have extremely high. People will be willing to spend hundreds of thousands of dollars for this one little loaf or one little gallon. Fortunately, we have lots of bread and lots of water all over the place. And so, this is a marginal utility curve. We're out here somewhere. So that each unit, because we deal in units in the real world, each unit, each gallon of water, each quart of water, or each pound of bread is very cheap because it's a low marginal value. When we choose units, as I say, we don't choose. It's like Crusoe with 20 logs instead of 1. Depends what the supply is. We have a huge supply, fortunately, a huge supply of both water and bread. Therefore, it's cheap. The units are cheap. On the other hand, with diamonds, supply is very rare, limited, scarce. That's true. We have a government cartel monopoly, which makes it scarcer. I'll get to that when we get to monopoly. It's run by the South African government, collaboration with De Beers and Company. But at any rate, it's still extremely scarce. There's only a few diamonds that's really, South Africa virtually has the only diamond mines. And so what you have then, even though diamonds, the first unit is much lower, say the least, than the first unit of bread or water, there are not that many units around as the supply is limited. So we have a higher price for diamonds on the market. In other words, a higher valuation by consumers for each unit, for each carat. I guess is the unit of weight of diamonds is called a carat. C-A-R-A-T. The value placed by people on each carat is much higher than the value placed on each loaf of bread. There's nothing wrong with that. There's nothing paradoxical. There's nothing unphilosophic. There's nothing unnatural about it. It's perfectly legitimate once you see what the whole picture is. Once you see the interpenetration between supply and valuation. It's marginal. Once you realize about the margin, this whole thing clears up. So that solves the value paradox. It took until the Austrians and other economists in 1871, the marginal utility theorists around 1871, to solve this paradox, so-called marginal utility school. For 100 years, economics have been misled by Adam Smith into this cul-de-sac where they couldn't analyze consumers' behavior, they couldn't analyze consumer actions because they couldn't understand the value paradox. And they allowed it and left themselves wide open for leftists to say, wow, gee, it's a terrible thing. And there's no conflict between production for profit and production for use. What's profitable is what's most useful to the consumer, most valuable, and the demand is highest. We'll get into the demand as we go along. Anyway, that solved the value paradox. Okay, the other thing about exchange, which I mentioned before, the other thing about any exchange that takes place in the market is that people wouldn't only exchange because it's more valuable for them. They prefer what they're getting to what they give up. They prefer the marginal units. In other words, if you exchange your labor service of 40 hours a week or whatever for a certain amount of money, or exchange money for loaves of bread or stereos or whatever, you're doing that because you prefer the value you're getting to the value you're giving up in exchange. And so each step of the way, each kind of exchange that's made on the market, literally millions of exchanges, benefit both parties to the exchange. That's also a very important concept. As I said, I might have mentioned it last time, I reiterate it. Both parties, what we have is a lattice work of two-person exchanges. In the market, we have there's always, for every unit exchange, there are two people or two groups and two commodities, including two goods and services. In other words, if I go downstairs and buy a newspaper, say I buy the Post, then you have two things. You have me and the news dealer, and I give the news dealer 35 cents. And I get the Post, all right? So I'm getting, both of us benefit from the exchange. I give up the 35 cents. I value getting the Post more than the 35 cents. The other hand, of course, the news dealer values the 35 cents a lot more than the Post. What does he need with 325 Posts? Pretty obvious in his situation. But at any rate, both of us then benefit. Each unit exchange has two people and two commodities, or two goods or services. One, in a money economy, money is always one part of this equation here. Money is exchanged for other things. So that if you work for IBM, if you graduate and work for IBM, you're exchanging your labor service for salary, for money. So that's, again, a situation with you and IBM, let's say. So even though IBM is not a person, it acts as a unit in this situation. So you have money and then labor service exchange for it. So each step of the way in this lattice work of exchanges is both parties benefit. Otherwise, they wouldn't make the exchange to do something else. They go home, they make some other exchange, they keep their money, they go to Bahamas or whatever. Okay, we now get to the most important. I talked about the demand curve last time. We get to the most important property of the demand curve, the only property which really is important, as a matter of fact. Remember, the demand curve is falling. That's all we really know about it. So you have on the y-axis, you have price, and the x-axis, you have quantity. And the demand curve tells you, it's really a demand schedule. It's a geometric representation of the demand schedule. It tells you, at this price, how much will be bought. The price of Wonder Bread is $10 a loaf. This much will be bought. If the price is $5 a loaf, this much. Whatever. And you get something like that. Okay? In other words, the cheaper the price, the more will be purchased. So you have a demand curve which is sloping, so-called falling demand curve which slopes downward and to the right. You don't know how it's sloping. You don't know exactly how. You don't know if it's linear. You don't know if it's steep or shallow or flat. All we know is that it's falling. Now the important property of the demand curve is how much, if this is like a freeze frame situation telling you what's in the mind of consumers. Of course, you don't know the demand curve. Who knows? You don't really know. All you know is that it's falling. There's no way to have an X-ray machine of the minds of every consumer and figure out, if you freeze today and find out, well, let's see, how much will they buy at different prices. But what you do know, as I say, is that it is falling. So there are two, the important property of the demand curve is, if you change the price, let's say if you cut the price from here to here, how much will the quantity increase? Okay? In other words, or at least in what direction? We know it will increase, we don't know by how much. If it increases just a little bit, you have a steep curve here. Well, let's see. It can either do that, or it can increase a lot. We have a much flatter curve, okay? Given the same point. Now there's this property of the man curve is called its elasticity. Once again, it's borrowing the prestige of physics, where the question, for example, is if you put different weights on a spring, how much will the spring give? Now there are two different kinds of definitions for elasticity. One kind, which is a textbook definition, there's nothing wrong with it; it's just kind of irrelevant. They go through a whole formula, namely, you take the percentage of the quantity change. In other words, if this is, let's say this is a 10% drop in price. If this is a 40% increase in elasticity, then you have all these ratios, etc. It's called a very elastic curve. If, on the other hand, you have a 10% drop in price and quantity only goes up by 5%, it's obviously very inelastic. So the more elastic is how much more give there is. In other words, how much the quantity will increase when the price falls. The reason why it's irrelevant is nobody knows anyway. And it's also the really important thing, it's qualitative, the really important thing for the businessman or for the industry is, will total revenue go up or down? That's what they really care about. If I cut the price, what's going to happen to my total revenue? That's what I want to focus on here. Now, total revenue, business income, net income, okay, is total revenue minus total cost. And this is a very simplified way of looking at it, but basically it is how much money do you take in a year over the transom or over the cash register or whatever, how much money do you pay out? If you take in $100,000 a year, you pay out $80,000, total cost, means your net profit is $20,000. Okay, so you're in fairly good shape. If, on the other hand, your total revenue is $60,000, you pay out $80,000, you're in pretty poor shape. It means you suffer net losses of $20,000. So therefore, total cost we'll get to later on in the course, but right now we're focusing on total revenue part. Total revenue is of any firm, or any person for that matter, equals the price of anything times the quantity sold. P times Q. Let's take let's take our Wonder Bread example. Okay. The curve is based on the schedule. Okay, let's say the price is $10 a loaf. You have very few loaves sold. Let's say 1,000. 1,000 very wealthy Wonder Bread freaks. Okay, so you have a total revenue then of P times Q equals TR. You sell for $10 a loaf. You sell 1,000 loaves. You get $10,000 total revenue. It's a very simple concept. Simple but important. If the price is $1, you might be selling 100,000 loaves. So then your total revenue is $100,000. If the price is a nickel a loaf, I don't know, you might be selling, let's say, 500,000. What's that? That's $5,000? Is that it? Anyway, that gives you an idea. You take the price per unit, multiply the number of units sold, and you get your total revenue. Okay? So what we're interested in here is what happens to total revenue. Okay. Let's see, this is the man curve here. Okay. Okay, here's price on the y-axis, quantity on the x-axis. If this is a certain amount, a certain price. If this is one point on the demand curve, this means that the price is, whatever this is, let's say $10 a loaf or $10 a case or whatever it happens to be, times 1,000. That means the total revenue is geometry of the total revenue is the total area. That's the price times the quantity. Then what happens if you lower the price? Okay? If, in the case of Wonder Bread, it's going to be a huge increase. Well, this is a 10. Yeah. Huge increase in total revenue. Other cases, it could be, of course, only even lower total revenue. If you have a relatively flat curve like that, you wind up, let's say, from here to here, with a new total revenue, which would be a lot bigger. In other words, in this diagram here, I've postulated, a fall in price leads to an increase in total revenue. Okay? Increase in TR. And then looking at this is $9 or something, whatever this is. If you go back, of course the reverse happens. In other words, you start with here, you raise the price to here, you get a big drop in total revenue. Right? So this is the other side of the coin, given the same 2 points. So here you have a rise in price leading to a fall in total revenue. This situation, when a demand curve is in this situation, it's called an elastic demand curve in that zone, in that region, because it can change from, it does change all the way up and down the curve. But what you have here, this is a definition of an elastic demand curve. In other words, the key thing that I'm focusing on here is the direction. What happens to total revenue with a change in price? If when you cut the price, if in other words quantity increases by greater proportion, you have an increase in total revenue. That's an elastic demand curve. You raise the price, then you have a fall in total revenue. So some demand curves will be elastic. You can't. It's not easy to forecast in advance what the demand curve will be, because it will change across the zone and it can be different from different things. Usually, it's considered wheat has an inelastic demand curve. It's not necessarily true, but at any rate. So that's an elastic demand curve. On the other hand, if you have a demand curve which is relatively steep, and goes like that, the fall in price, then you have this total revenue. The new total revenue, the new area will be smaller. In other words, the increase in quantity is not enough to offset the drop in price. So the result will be a lower total revenue. I think I even clearer here, like that. So in this situation, where a fall in price leads to a drop in fall in total revenue. Okay? Or looking at it again the other way around, if you raise the price from here to here, you got an increase in total revenue. Okay? So that's rise in price. This is something the businessmen are very interested in. They don't care that much about the percentage of the amount and all that, the formula. They care about what happens to the damn total revenue. Okay, so this is, because in the real world, businessmen don't know the demand curves are not listed on the book for them. They have to try to find out. It's not easy to find out. It's part of the job of the entrepreneur, the businessman, to try to figure out what's going on. Okay, so rise in price leads to then an increase in total revenue. This situation is called an inelastic demand curve. Inelastic. Okay? So in other words, we're setting up here a new definition of elastic and inelastic. Instead of concentrating on percentages, what I'm saying is I'm concentrating on the direction of total revenue. If the total revenue increases with a fall in price, you have an elastic demand curve. If it drops with a fall in price, you have an inelastic demand curve. And vice versa. If the total revenue falls off an increase in price, you have a elastic demand curve. If it goes up an increase in price, you have an inelastic demand curve. So what can we say about when things will be elastic or inelastic? Well, for one thing, we can say that other things being equal, given the range of choice, a larger range of choice will lead to a greater elasticity. In other words, let's say this is back to our Wonder Bread example. Here's the price of Wonder Bread. Say this is $1 a loaf. And let's say Mr. Wonder, huge increase in price. Sales are going to fall off tremendously because all the other breads will remain the same price. Rolls, bread, everything is $1 a loaf or so. He's raising his price to $5, $10 a loaf. It means a tremendous falling off. It means the demand curve is very elastic for Wonder Bread. So you have a big falling off in total revenue. So that's one of the reasons he's not going to do it if he's sane. On the other hand, if all the breads go up together for one reason or another, for some kind of a situation, all bread prices go up to $2. That's a different story. Then there'll still be a falling off, but people won't be able to shift out fast from out of Wonder Bread into Pepperidge Farm or whatever. They'll all be going up. So in that situation, it'd be much steeper. It could still be elastic, but it'd be less elastic than for each given firm or each given brand. Same way on the way down. If you have If Mr. Wonder cuts his price and all the others remain the same, he'll pick up a lot of sales. It's going to be a very elastic demand. On the other hand, if all bread prices go down, they'll pick up some, but not as much. So one thing we could conclude from this is that the demand curve in all cases, regardless of how elastic the demand curve is, the demand curve for the firm, any given firm, is more elastic than the demand curve for the industry as a whole. Unless, of course, there's only one firm in the industry, in which case it's the same thing. So, more elastic than the demand for the industry. And this sets up a temptation. In the case of, there's a big gap, and we'll see later on, there's various reasons why demand curve for every firm is going to be elastic, regardless of what firm it is. It's going to be elastic. Where some demand curves for industries are inelastic and some are elastic. When you have a big gap between the two of them, when say the demand curve for each firm is quite elastic, and the demand curve for the industry as a whole is inelastic, it sets up a temptation for a cartel agreement among the firms, because it means that they can get together. I'll get to that later on when we get to monopoly. If they can get together and agree to cut production and raise price, they'll all benefit. All the firms will benefit, because then they can, let's say they raise price by 20%, their production gets cut by 10%, they pick up more total revenue. But it's only if each firm will keep the agreement. As I'll point out later on in the course, there are inexorable conditions in the free market that lead to a very quick breaking up of all cartel agreements. The only reason why a cartel agreement ever remains in action is because the government enforces it. When the government steps in, what's the matter out there? Better close the door. What? Oh, God, we only have a few minutes. Eager class for next hour, I say. Well, God bless them. Okay, so where was I? What was I talking about? Cartel, yeah. So if a cartel, the only time a cartel will last for any length of time is when the government steps in and enforces it, prevents new competition from coming in, prevents anybody from breaking the agreement. And this is what's happening in Europe a lot and so forth and so on. We'll get to that later. This is just a teaser on cartels. But that sets up a big gap between the industry demand curve and the firm demand curve, sets up the conditions for at least a temptation for that sort of agreement. All right. Okay, now there's all these demand curves, they might look flat or steep, but you can only tell the relative elasticity when they're from the same point. If you have this kind of situation and going down from that price, you have a flat curve, this is a steep curve, you know this is more elastic than that. Okay. But if you just look at a curve like that, or look at that, it's not necessarily true that this will be more elastic throughout the entire range. As a matter of fact, when you get up high enough in this thing, it'll be elastic, even if it's steep. You get to the point finally where people can't afford to buy more, whatever it is, as the price goes up, even if it's something which is inelastic, even if it's wheat or something like that. So you can't gauge by looking at it. You can only gauge by looking at the focal point here and looking at it, what happens when you go up or down from that point, where they have a common point. So as I say, the elasticities will differ over the range of each curve, except for 3 curves, which are hypothetical, which usually never exist. The only cases where the elasticity is constant throughout the entire range of the curve, and those of you who are mathematically inclined will see the reason for this. 3 curves. One is the situation where you have an absolutely horizontal demand curve. We've already seen you can't have it. This is one of my big gripes with the later chapters on so-called perfect competition. There ain't no such thing because the demand curve always has to be falling. If you ever had this crazy situation where it means you could produce as much as you want, sell at the same price, this would be an infinite elasticity. E, epsilon, fireplace, epsilon would be infinite size throughout the entire range of the curve. On the other hand, if you had a vertical demand curve, absolutely vertical, also which can't exist, we've already gone through quite a while explaining that, the elasticity would be 0 throughout. It means regardless of what happens, you never have a change one way or the other in the quantity, which is, again, absurd. This is mathematical extreme cases. Another constant elasticity, which is not absurd, I doubt would ever happen. I mean, it's extremely unrealistic, let's put it that way. In a situation where the demand curve is a rectangular hyperbola, it goes in like that, such that the total revenue is always constant. In other words, the area under the curve is always constant. Like that. So regardless of what the price is, consumers always spend the same amount of money. That could happen. It could even happen for certain individual ranges, but there's no reason to assume it happens. I mean, there's no evidence it ever happens and whatever. But it's not illogical, it's not absurd like the other 2 cases. Now, oddly enough, in the history of economics, demand curves first come in about 1920. For about 25 years or so, the textbook demand curves were always like this. It's a totally insane situation. This is the way it was shaped. And so they were assuming it all the time, that really assumes away the whole point, which is changes in elasticity, or changes in total revenue. It's a very weird kind of assumption. Finally, in about 1943 or so, Professor Stiegler was a young economist then, wrote a price theory textbook, I guess which would now be called Intermediate Micro. And he since has gotten a Nobel Prize, etc. Anyway, he starts off and he said, why are these like this? There's no evidence for this, no reason for it, just sort of fashion. And he says, the hell with it. It's ridiculous. Let's make it a straight line. So from then on, all the demand curves in the textbook have been straight lines. At least you don't have the assumption of constant total revenue. On the other hand, there's no evidence of a straight line either. It's purely for convenience. It could easily be like that. No evidence for a straight line. So it's still, I think Donald McCluskey is sort of a maverick type, very interesting economist, kind of a nut, very interesting. He has a textbook now recently on intermediate micro. He has demand curves like that. Well, okay, I mean, but I think I still prefer using a straight line. It's more simple to do it. But always keep in mind that this is only for convenience. So that, see, what happens later on in the course, they start using tangencies. There was also some very important conclusions from nonsense. There's no reason. If it ain't straight line, it ain't going to be tangent. Okay? So at any rate, just keep that in mind. That what happens in economics has happened for many years now is that they start using math or diagrams as a convenience, as sort of a graphic illustration of economic concepts. And after about some years of doing that, they start thinking of the graphs as good ends in themselves. And they forget about the economics. They start talking about tangencies and all sorts of other stuff. So we're trying to keep close to earth here. At any rate, this is so elasticity is a major property of demand curve. It's either elastic or inelastic, which means you always have a situation where total revenue either falls or increases when changes in price. And it's obviously extremely important for businessmen to try to figure out what's going to happen. In real life, there are no given demand curves. Just as there are no given cost curves later on. Businessmen are trying to find out what will happen if they raise the price or lower the price. And it's a trial and error kind of procedure. And it's much of it is hunch and based on their intuitive insight into the market, which is of course based on knowledge, but it's based on a sort of knowledge the economists don't have, because we're not in the whatever the fish market of the computer market, whatever it is. Each market is different, has different people in it, different all sorts of stuff going on, dynamics, which only people involved in it can figure out what's going on. So, okay, I think that's enough for today. Press on.